Hello.
Yeah, hello. Good everyone. Please can you confirm you can see my screen?
Yes.
Yes, we can see
Oh,
it.
okay. Yeah, so today I'll be taking you through Docker, what's Docker and why we need it. And we'll actually take a little practical on it also. So for the next less than an hour now. So I'll be the one to take you through what Docker is. So the course outlines already the material is well explanatory already. So I'll just try and guide you. Then the real practical aspects, I also try to make it more simpler for everyone. Yeah. So Docker is a platform that allows you as a developer to package your application and dependencies to a container, so it can run consistently anywhere on your laptop, a server, or cloud. So that's what basically Docker is. Docker is just one of the software out there that it will be able for us to. I don't know if you actually tried VM virtual machine before, when in the olden days where developers wanted to test different kind of um, software that they built. Most times they do use VMs on their machine so that they'll be able to have access to different environments to be able to test it. Or at times, if they are working in team, they do have some issues that deals with operating system mostly. So, but we actually get to there also. Don't let me rush it. So then now let's see. Let's take a scenario that just think of it as something that you arrive with your code. You as a developer now, you write the code on your laptop and it actually works perfectly on your laptop. But when you share it to probably one of your team members to run it, it actually breaks. So they try to fix it every time, like okay, everything is well, but the code keeps breaking. So that means there is difference in operating system. There might not be difference at times also. You might be using the same kind of operating system. Probably you are both using Windows or Linux or Mac. Also, it might be Python version or any type of runtime environment you're using. It might be different in the version that will lead to the code breaking, or the libraries that are being used to deploy to build the app, or some systems configuration might actually be a cause also. So that's exactly what Docker actually came to solve for us. So the issue of me running a code on my laptop that works perfectly and then sending it to my teammate or colleagues to actually try it out. Okay, I see something I've built and running it on their end, they are encounter different kind of issues. That's exactly why Docker is here for us. So first thing that Docker actually did is consistency. So the it was my machine problem actually been solved because the application will be packed in an isolated environment that whenever you wanted to run it, you just run it, all the dependencies, everything, the runtime, everything is there. So it doesn't care whether your laptop is the only thing that Docker needs is that you have Docker daemon, you have your Docker installed properly, and you'll be able to run any code or anything. Yeah. So at times too, you might be in the same environment everywhere, and then so it might be used to stage the to separate the development stage. Okay, we have development stage testing or staging at times, then to production also. And Docker, one of the very good thing about Docker is that it's more easy to deploy. When you're trying to deploy the application, just package everything once and then deploy it anywhere. So there is no much complex setup needed. The only thing you need to do is to make your make sure your Docker file is well written. So we'll get there, we'll get to know what Docker file is all about. So as I've said earlier, isolation. So that's exactly each apps actually have its own container. Like you'll be running in an isolated environment. So there won't be any conflicts between the projects that probably they were trying to use the same thing, or maybe for example now one of the scenario that I can easily use to explain that is, on our laptop at times you are running two application. Probably you have two application that wanted to use a single port. Yes, probably you are running two different front end. They wanted to access the same port. One will actually have to go down for one to be able to run. The same thing now happens in Docker also, but not in both aspects. It depends on, we are talking about the runtime, the dependency, and everything. Even if both application actually needs the same runtime, everything at the time, there won't be conflict. There won't be any conflicts between them. So they will both be using, because they are actually running in isolated environment. The only issue we might also have is that issue of port. If you actually open it, if you open the port, if you map the port to our local machine, and then you actually wanted to map like two, three to a single port, there might be an issue too. But for an application that's running on its own, there won't be any issue. Then portability. So you'll be able to actually move your app from one cloud providers to another easily, very easy, no much complete or setup stuff needed. And then Docker actually works on Windows, Mac, and Linux when type. So, and for the machine learning or stimulate apps specifically that have actually been introduced to earlier. So should be able to bundle the code, all the model, the code dependencies all together and then deploy it to any kind of cloud platform seamlessly. So, and also people that don't have anything installed on their laptop except for Docker, they can easily run your code and test it. That's one of the good thing about it. So if you as a developer now wanted to share your products that you've built or a project that you've built and you package with Docker deployed. If someone wanted to test it, the only thing the person actually need to test it is to have Docker installed properly on their laptop. The moment they have it installed properly, they should be able to run it without any issue. They should be able to fetch it from your public repository and they should be able to run it without any issue. And now let's move on to Docker basic concepts. Something that actually that makes up Docker itself. So we have container. A container is a lightweight standalone package that includes your code, the runtime you are using, maybe Python, Node, any runtime, maybe any type of runtime. Then also the libraries they are used when developing the application. So for Python, basically at times we are talking about machine learning applications. We do this with pandas, Kitlane, and then Streamlit or thereabouts. And also all the system tools used and some settings. So everything will be inside your Docker container. Everything. No, everything will be inside the container itself, like it will be running as a standalone. So there won't be any issue. And so let's just see this, just think of it as a shipping container for your application, everything packed and ready to go. Yeah. So this container that's been mentioned, we'll later get to when talking about container orchestration also. So the same container that we are in is exactly the same thing as the container that's used in shipping. So when we are shipping, when they are shipping goods from one country to another, basically in a container, there will be different goods inside it that will be packed there. Most times, they just pack everything there. And once they pack it like that, they'll get to load it. So inside that container like that, it's a stand alone. Everything that's happening there, the other one is less concerned about it. It cannot affect it. So that's exactly how Docker also works. Inside the container like this, everything works alone, just stand alone. The only thing that might have used to affect the other is that the space that the container will be occupying on the ship, another container cannot occupy the same space, and that's exactly Docker. If you run a Docker container, the port that that container will be occupying on your laptop, another port cannot use it. So that's just it in scenario. So when we later got to orchestration, you see how we can actually manage a lot of containers at the time, the same way more containers is being shipped from one country to another. All right. Then image. Talk about image. An image is a blueprint template for creating containers. All right. So when after we package our code, when the image is what we actually got built that we built for us, and then it's from there when we now run the image that we have containers. So all the codes now, the moment we write the code, Dockerify everything packed together, we now run it to build it to be an image, right? So once it becomes an image, one, it will become just one image. So from that image, they will now be able to run container as many containers as possible. Yeah, and you can easily install, like, you can easily fetch your and download your image for a particular app. You pull it. So when you have the image, you can run multiple containers. If you run container, you can easily stop container, remove container. But for the image, you can still use it multiple times unless you wanted to clean everything and then just feel like you want to restore it. All right. So So image is just like a recipe, and the container is actually the meal cooked for that recipe. Yes. So and then you can, as I've said, you can just create multiple containers from one image, multiple containers. Yes. So an image is a reusable stuff. You can just create a container. When you feel okay, you're not using it again, you bring it down by removing it or stop it. Then the later one, you can just bring on another one. Then Docker file. So this is the text file with introduction on how to build the Docker image. So when we're building Docker image, this is where we actually write the configuration, everything needed for us to be able to build the Docker image. And so the disciple example that I was given, so it's just like a card that takes Docker how to prepare a container. Yes, that okay, oh, this kind of food I want for our disciple. So that's just how to prepare Docker. Well, how to tell Docker that, oh, this is what we want. This is the configuration we want for our container. This is the port that we want it to be running. This and that. Yeah. So and then Docker Hub. Docker Hub is a cloud-based registry where you can store and share Docker images, local Docker images, yes. So just think of it as GitHub, but for Docker images. So all the Docker images that we built, you can have them stored on your repository, just as we do. Normal developers store their codes on GitHub or any version controlling system like that. So that's just what Docker Hub is. Now, let's not take a look at writing a simple Docker file. If you wanted to write a simple Docker file, actually have some step by step that we should follow, the instruction for us to be able to build our image. The basic structure, the first thing in every Docker image is to have your base image. So this base image is very, very important. That means the runtime that your computer, that your container is going to be using. Right? So it's very, very important to have it. That's why every Docker container always starts with from. So then the next one is to set the working directory. So inside this container itself, inside the image, we can have just like you have normal on Mac, on Linux systems, yeah, all the file structures. So the same thing happens to Docker too. That the way your structure, your files being structured. So now that we've created a working directory like this, that means this app, the folder is what we're going to be using for our codes, to have our code inside it that will run everything inside it. Right. So in case there is any issue, you wanted to check whether the file is being copied properly, you can easily navigate to this folder and then check it. Okay, yes, this is all the codes are completed, or if there is any issue with it, you can also see. Then when you are copying files, this command. Notice that all the commands for Docker is being written in capital letter when you're writing Docker file. So they are being written in capital letter. So when you're copying, just copy that. Oh, copy dot. This dot means everything in this correct directory. That's what this dot means. Then there will be space here. There is space here. So copy it to the app. When we go to where we are talking about some best practices in Docker, we'll mention something regarding all these steps where you're trying to copy files. Then when you are installing dependencies, use run, then you run whatever you wanted to run. You can install, if you already add your requirements to txt that contain everything needed, right? You can just easily install it straight away. But if you don't have that, maybe the what you're building doesn't require you having much libraries or dependencies like that. You can easily specify which type of requirement, which type of libraries or anything you want to install. You can just specify it directly. That should be pip installed wherever. Yeah, because this one is why that's why I'm putting the R there. Then you can expose port. Though this port is just for like more of like a readable, just for readable, right? For us to be able to know that just for readability. So it's not like it will really, really work. Like the moment you use this expose port, when you are running your container, you still have to specify the port that you want it to be running on your local machine. Alright. So basically it's just there. Not like it doesn't really have effect on your real laptop. The moment you run this application, when you are running it, you still have to specify, okay, I want this thing to run on this specific port. Right? So then if you want the application, the command for us to run the application, just input it there. It might not be only this. If you are running with if you are working with any other Python stuff, maybe Unicorn, anything, you can just input it there. The good thing is like the main thing is for you to just know the command that you need to run it. So that's normal command that you use to run your code normally. So that's what goes here. So now let's okay, I've already tried to explain everything very well anyway. So you are still trying to break down. So we just tried with the prebuilt Python 3.9. Yeah, for example, I'm just saying. So this prebuilt Python 3.9 also, you might be wondering that okay, when we say every Docker file must actually start with a um with one image, base image, referred to as base image. All these images to cause this Python too, if you are using Python here, like from Python, it's not just normal Python that we do use, it's also in Docker form, like image form, containerized form. Right? So how do they now create that one? Because as for Python, which type of environment do they use? Like which type of runtime are they going to use? While some of these page may actually they might just use something like an operating system like probably Ubuntu or stuff like that. Majority of them they do start from scratch when they are starting them. So if you go a little bit further, we see that okay, if you wanted to create your own image from scratch, you can start it from scratch. But that one is more of like an enterprise stuff, like business, right? Then the slim, yeah. So this one is very very important also. So in Docker, there are some little things that we need to take note. So this slim now, if you are building your image, if you don't want your image to just get larger, unnecessarily large, right, there are some things that you take into consideration. One of it is where you are fetching your base image. You know the type of base image you must fetch. So this slim is one of the most easiest, like most compatible one that all the unnecessary files have been scraped out. So you're not going to fetch them. For example, now if you just use ordinary 3.9 like Python 3.9. After building your image, you might be seeing something like 1.2 for one single image. When you try to use this slim, you can use a smaller and lightweight version. So when you try to use the slim, you might actually from that 1.2, you might change like something like 100 MB from that 1.2 or 110, 120 thereabout. Like just you see that there will be a very like significant changes from that thing. And the more all these things takes, like the more all this the type of base image that you use, yes, it will actually add to the space for the image. It will actually increase the space and also the time taken for you to be able to build your image also. And so you said working directly inside your container, just like doing normal change directory in Linux, right? So then you copy all the files from your current directory. As I've said, just copy everything into the folder that you want to use, then run the package installed and everything. So as developer is developing or you as a developer also you have add every the packages needed into the requirement.txt. So instead of you to come here and be listing them one by one, you just install you just point this thing to Docker. Docker will understand that oh there is a requirements.txt file that has all the packages needed and it actually run it. So everything will run during the image build. This the command will run during the image build. So this documents that the app port uses this. Can you see? So it does document, not that it will actually effectively open that port the moment you run your container. That document is like it's just for documentation. And this command is basically, as I've said, just to run your container. The moment you want to run your container, this is the command that will start the container. So after you finish writing your code now, for example, if you are writing like a front end application or you're building a front end application, well, the thing to start your application is to use npm run dev or run production or anything. So those are the commands that you just add there. Just add it there. Then just launch it any if you are building your Streamlit app, you can just launch it if this is what you are building, right? So now this is how Docker file, the what Docker workflow in general actually works. Then you write your Docker file, you build the image, the Docker image. Then after that you run container. Use Docker run to run the container. Then you push Running means just test, for example, right? Then just push to Docker up. After you push to Docker up, then you can deploy from your Docker up. And from that Docker up also, the same way people can actually fork your repository on GitHub, they can also pull this your code in your public repository. You make it public, so they can also pull it if it's something that actually interests them. They can pull and use also. So now the practical aspect is installing Docker. I don't know if every one of us already have Docker installed, and if not, can easily do that. So for Windows, there is no Docker daemon for it normally. So there is only Docker desktop. And so as far as I'm concerned, I've been using Docker on Linux, and that one has been very, very comfortable for me. But for people that couldn't, probably for developers that don't just wanted to be able to experience the sweetness of Docker at times, they do also use Docker desktop. Yeah. But if you want to get a lot done, as I've known, right, you need to be using it your Docker, probably Mac user for Mac user and also for no, for Linux, yes. So there is Docker desktop on Mac and Windows, but for Linux, this is how you install it. Then after installation, you confirm your version by Docker using Docker version, right? Then if you're on Linux, can you just do this so that you're able to enable your Docker? So you have to start it every time you reboot your laptop or you just restart your laptop. You understand? So now when the practical aspect of it is now building our first container. So we can just create a Python app, a simple Python application can then inside the file by app just put this print statement, two of it from Docker and then right. Then for the requirement tst, so far we are not using any package or anything that we needed, so you don't need this, we won't be needing it. Right. And then so inside the Docker file, these are things that we have there. Just simple as this, and you finish building a Docker image. You call your runtime, the working directory, then you copy all the code. So when you are copying like that, that means the directory where your Docker file is, every other thing there will be copied, right? And you know that when you are pushing your image on GitHub, there is a file called git init, git ignore. So that git ignore means things that you don't want to, some things that you don't want to push to your Docker, to your repository, to your GitHub repository, right? Probably like your environment files. So the same thing happens in Docker also. Things that you don't want to push to your Docker file, you can easily use Docker ignore. There is a file like that. So use Docker ignore. And the good aspect is while you are in our GitHub, in Git ignore, there are some files that you won't have to ignore them in building your Docker image, like the Docker file itself. But when you are building the image, there are some files that are irrelevant, even though they are still relevant to the codes. But if you are building the code, you just have to add them to the ignore file. That you don't have to add to the space by the image, because everything you add there will actually increase the space taken by the container image, like by the image, yes. So now, after we've written our code, go to container to terminal and then you type this that Docker build, then you tag this thing is tag and build my first Docker app. So this dot also is pointing that okay, in this current directory, look for a Docker file, right? And then you build it. So the explanation on that is that Docker build, you actually build an image. So this tag means it might be the tag or the name, right? The string is referring to a tag or name. And that name that we're given to this is my first app. So this the dot means we are using the current directory. So that current directory means Docker will look for a Docker file in that current environment. At times, you might have multiple Docker file. Maybe you have one for your dev environment, another one for your station, another one for your production. You can easily denote them by adding something that looks like an extension. Probably you write a Docker file .dev, something like that, or well, but that one is more recommended. Because if you actually name it something that Docker don't understand, that means the file Docker might not be able to recognize it as a Docker file. But if you use something like that, okay, dot file dot production. But that one now, when you wanted to build, that means you have to point to them that, oh, this is the file you wanted to use. Then you use flag F to point out, okay, this is the file that you wanted to build. So now we are running the container. If you want to run the container, just call the container directly that you've built. We've built an image. So now I want to run a container. Just use Docker run that image. So from this image, Docker will create a container for us. And once the container is created for us, it just print this thing because it automatically runs our code for us. This is the command that's been run. So just see this in our container, and then so we've actually finished building that image. Now, if you want to build, if you want to push it to Docker Hub, though Docker Hub is not the only repository that we have, there is still different repository. There is different AWS at majority of the cloud providers they have their image repository. For AWS now they have ECR, Elastic Container Repository, right? Majority of them rather they have their repository. But because Docker, as you can see, Docker Hub. So this one is coming directly from Docker. That's why most times people actually prefer to use this. So just sign up for a free account, you have your username, and you must use your username because if you intend to build this and push it to your Docker hub, you must use your Docker username, like the Docker hub username by building this. Then just log in via terminal. One of the commands of Docker is Docker login. The moment you use Docker login like this, it will try to authenticate you, to authenticate from browser itself and then bring you back here. And if you wanted to just input the password as once, you can just use user and then token and your password. You understand? You can just try and check more about Docker Hub then app, Docker login app, right in the command. So you see the list, all the commands that will be listed here. Or if you use the Docker login also directly, you can just ask your times that okay, your password and your username and password, and you input it. Then if you now want to push this thing, you see, we are just trying to tag this thing. We are changing the name from my first app to your username and your first and this previous name. If you already know that okay, this thing you are going to be building it, you are going to be pushing it directly to your username to your Docker app, you can easily build it together. Like from here, when you are building your application like this, when you are tagging it, yeah, yes, you can just add it here directly like that. Oh, Docker build tag your username slash the name that you wanted to give the image. Yeah. So after you tag this, just use your username and make sure this is your username on Docker. Uh, so that's the requirement for you to be able to push to your account. So now you can just push to Docker Hub by using Docker push. That's just a very similar command when it comes to GitHub also. So if you are very conversant with GitHub, that means if you have issue with all this. Docker push, you can just put Docker push and then the image that we just tagged now, or the one that we just built. Then you can go to Docker Hub and check your repository to verify that oh, this thing has been pushed. And very good thing about Docker is for everything we've been saying about Docker since when it comes to building push, Docker will always build and push with steps to finish with one steps before moving to the other another. If we wanted to push also to push with different steps. So all the steps when you wanted to repeat something. So the caching system for Docker is a very great like is a great one. That means if you are built a previous Docker now, the first time you are building an image, for example, it takes you like 5 minutes. And later on you make your changes and you still wanted to rebuild the same image, you rest assured that the next building is not going to take up to that 5 minutes. It's not going to take up to that 5 minutes, except if you like to do some certain things, it might take you like 4 minutes. Though it's definitely going to be less, if you understand. But still, there are some. best practices to take into consideration that from that 5 minutes that take you in your first build, the next build might take you in a few seconds. Yeah. So if you follow some best practices and go to the part that will show you, so you can actually see, then you just verify, okay, you have it there. So some of the commands that are very essential when it comes to Docker is the building, you said, the build your image, Docker list. So you just use Docker images and you see all your containers, all your images rather. Then if you want to run a container, use Docker run, then you put the image name. The PS means all the running containers. So you can just list the running container. If you want to list all the containers, the ones that are running and the ones that are not running or be stopped, you can just have flag A. That means all. If you add it there, so everything will be listed. The one that are stopped, everything will be there. Okay, this is it, including the stopped ones. You can just list all the containers. This one is specifically for the running one, right? So if you have flag A, that means list all the Docker containers, whether in running state or not, list it. So if you want to stop a particular container, you use Docker stop, then you put container ID. That container ID for Docker is a unique one. So every Docker container you run you will have their unique image, and it's up to 64 if I don't miss it. So, and you don't have to type all the 64 if you wanted to use it. I just use the first three numbers or letters at times. So you can just use the first three, and Docker will understand that, oh, you are referring to this. So it's a unique ID for each container. So if you want to remove a container, just remove them. And if you want to remove an image, you just add I to this, to the RM. If you add I to this, it will understand that, okay, you're trying to remove an image, not just ordinary container. Then if you now want to pull image from Docker, you use Docker pull. If you use Docker pull, you have, the username for that. For the username will be the repository name, for example, will be the person's account name that you're getting from, and this will be the repository name, right? Then you can just push this with this command to your Docker, your build image, your image. You can just push it to your Docker up with that, with this command. So here is the summary of what we've learned so far. Docker package app with all dependencies. So that's the basic usefulness of Docker, then containers versus image versus Docker files, right? What container is, and images, and also what does Docker file means. When we say Docker file, what do we mean? And how to write the basic Docker file, how to build and run containers, and how to push images to Docker Hub. And so, why this actually matters is to know all the Streamlit app, the machine learning application I've been building, right? So for us to be able to deploy it into cloud. So the next session will actually be the next class that will have the next session will trying to containerize the application, built everything that you've run. So you can also take this as a practice on your own. Just create a simple Python script that prints your name, right? So you write it might just be print, then use the normal print function in Python. Then you write another Docker file for it, you build around the container, then you push to GitHub image, and then you share your Docker Hub link to people. Okay, you can share it, and then so you're able to see. So that's just the common questions that at times people do ask that, okay, is Docker free? Yes, it's actually free for personal use and small businesses. So there is enterprise also that can pay for, but normally it's free. So yeah, so if you don't, is it a must? Like, do I need to know Linux to use Docker? No, but basic command line knowledge actually helps. You understand? So, difference between Docker and virtual images. Yeah, I think I mentioned virtual images when you're talking about when I was starting out. So, Docker containers share the host's OS kernel image. Yeah, that just make it more lightweight. But for VMs actually include the full OS. So, if you wanted to run your VM now, the same image that you download for your laptop, you wanted to install your laptop, it's the same thing, you just download it. The installation guide, the installation steps is the only different thing, like it's the different thing that you have. But ideally, you use the same file. That means it's more heavier, right? And that makes Docker more easy to use and ready to use for us and go to. So you can actually run your Docker on your laptop, if any kind of laptop you're running, right? So and our session will definitely be authorizing a real application, right? You can see. But let's just try and see some commands. Let's try and look into some commands like come in. Let me. Yeah, please can you see my screen now? My confirm you can see my cursor, my editor app. Hello. Okay. Okay.
Yeah,
That's
yeah,
very
yeah. You can see your
okay.
screen.
I can
Oh,
see.
okay. So the codes that we just tried in let me copy it so that to make it more faster for us. Call me. So please, yeah. So if you wanted to run this normally, you just use your Python. So can you see now? We have the results. It's been printed hello from Docker, and this is my first containerized app. Though we've not containerized it. So let's now see. Let's now go ahead and containerize. You label your Docker with Docker file. The moment I write Docker file, can you see that this file automatically changed to Docker image, a Docker logo? Yeah. So now let me copy the simple code there. Yeah. Yes. Let me confirm this will work without adding three. Okay. So it still work. So now for us to be able to see, I'm trying to. Uh, so the auto suggestion is trying to tell me whether I have some Python requirements. Like let me just add it and then. So if you have any packages that I want to use, you call me. So you just create this requirement to TXT file like this, and you list all the packages here in case you have any in your application, right? And also the Docker ignore that I mentioned that works exactly the same thing as like git ignore. So you start it also with dots, and then you write Docker, then ignore like this. Can you see it also changes to Docker image? So if you wanted to ignore anything that you don't want it inside your Docker image, you can just use this ignore. That means when Docker runs, soon copy the file into that part.
Can you
So
zoom? Can you zoom your? Can you zoom your? Hello. Can you zoom out your screen? It's too tiny.
okay,
Can you zoom out your screen? It's too tiny, please.
okay. Can you see now? Is it better now? I think it's
There's
better
no
now, right?
changes.
No changes.
There is no change.
I've
Yeah.
zoomed it out. Sorry.
Yeah.
I'm
Zoom
coming.
it
Let
out so
me.
that it can be bold. It's too tiny.
What about now?
Uh-huh. This is now better. It's
Okay.
better now.
Okay.
It's
Okay.
better now. Yeah.
Okay. I get that. Yeah. So let's now try to build this. The Docker. Let's just use the Docker build. The Docker build. So we now use T to name it that okay, first app. Okay, let's use the same name you used there. So if you wanted to build like that, first thing is Docker will fetch this if it's not on your laptop before the base image. So it will fetch it, create the working directory, copy all the codes, everything here will be copied except if you actually add any file inside this Docker file. That's the only thing that will not be copied when this copy command runs. Then it will run this command to install the necessary requirements and also to just start the container. Like it will place this at the running command, right? So now let's build our image. What was that? Oh, I didn't add dots. That means the current directory, the file that I want to build, right? Uh-huh. So that's successful. So all the steps run in general is nine, but basically all the steps that is needed majorly is four. Can you see two or four? The first one is to fetch this to set our base image, and that's all this. That's what all this is all about. So the working directory set the working directory, and you'll be seeing the time here so that you can know the time saved when next you actually run it. You understand? So running this one you don't have much to run because you don't have anything to install there, so it won't run. So layers. What I was trying to say earlier when I was saying steps is the layers. So everything that Docker built them in layers. So to be in layers, now let's try to run our app. Yes, we will actually build the app. What we now have is to run the application by just using Docker run. Then my first app, right? So you see that I use Docker run and I got the same thing I got when I tried when I ran this file. You see, so that's the same thing. So I think being our application or anything that we built is something that has to do with running that will consume probably that will just use a port. So the exact behavior that we experience while we run it normally is the same thing we will experience when we run it on Docker. You understand? The only thing that will be different is that if you run a container now without mapping it to your I think we'll later look into that. How to run the normal this thing in our next class when you're building when you're trying to Dockerize the application, right? So we'll look into that. Let's just tell more about the ports. So now that's the exact and if you now want to push this into your Docker hub, you understand? First thing is for us to tag this Docker tag, then my first app, then use your username. Let me use my username here. Yes, so that's my username and my first app. So if you tag it like that, it has been tagged successfully. So if you now want to push, very easy for us to push. Just be docker push, right? So can you see everything is being pushed in layer? Yeah, so it's done. So this is the unique ID for the image that's been built, right? And the size of the image is so it almost is 1 MB, 1780 something MB. Will it be MB? Probably that's in KB. Cannot up to MB. Because if it is MB, that means that's 1.7 gig. It cannot be up to that. So what I mean by layers is that you see these layers, first push one layer to go ahead and push another, go ahead and push another one, and that's just it. So the reason this thing was able to push directly to my own repository is because I've logged in already. So if you're here to log in, first thing before pushing is you log in. So if you try to log in like that, right? So login succeeds because I already have my this thing logged in already. But if you wanted to log out and log into another account, this is the command. Or if you wanted to log in for the first time, once you use Docker login, you see you'll be prompted with your um password and user, right? And you can easily use token also. There's a place for us on your Docker Hub account. You can just use Docker token. You can use Docker token so to log in instead of password. So in case you are trying to log in, you're trying to access from another person's laptop, moment after sometimes you have finished, you can just and also you can set the expiring time, the time that you want it to expire, right? You can set it there. So now let's just quickly. I don't know if anyone has a question. Please, if you have a question, you can ask because we're almost come to the end of the class now.
Yes, I have a question, please.
Okay, okay, okay. Please, go ahead.
Okay, my question is in the base image where you have the command slim. My question, I can see that we have Python 3.9. I mean dash slim. Is that the standard image type that we're supposed to use, or so what determines that? Or for example, if I don't have I have Python 3.7 on my system, do I have to install Python 3.9? Or I just want to know what's the standard for the base slim image, please.
Oh, okay. Let me just try to confirm that I understand your question. Are you asking about Python 3.9 itself or the Slim that's been attached to it?
No, 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 I understand the concept of the slim, that you want to make it you want to strip it down to the BRS minimum. So my
Okay, okay.
question my question itself is Python 3.9 the standard requirement for that, or
Okay,
it
okay.
can be any version of Python?
Okay, okay. So it can actually be any version of Python, but it depends on your application, what you actually use to run your application. You know, when you're developing your application, it's because this is just normal text stuff. That's why you don't have, even when you use 3.6, anything, it still work because it's just normal run stuff like this, like print statement. But for some application that you develop with 3.9, and you're trying 3.10 or 3.11, 3.10, you should understand. So if you now develop your application with that, and when it comes to Docker, you're now using a lesser version, you might be having issues for the application to be able to run. So what determines this base image is your application. If you have developed a node application now, probably in JavaScript, you wrote your application in JavaScript. If you are coming here to set your base image, it definitely be Node. It won't be Python at all. So what determines the base image? The base image is just like the run time, like the run time. What do you want it? You want your application to be run on? Yes.
Okay, if I understand you very well, sir, that means the environment itself.
Yes.
Okay, okay. I just want to be clear about that. Like, for example, you can have 3.9 environment, you can have 3.7 environment, depending on. So
Okay, yeah, it actually depends. And there's something called multi-stage build. I think we'll later look into that. So that multi-stage build means if you have many steps that you wanted to run, many steps, like the application requires a lot of things in Docker file, you can actually just split the step. Probably the first step, like you have from twice. That means the first from, you just use that one to install the dependencies. So basically, what that multi-stage will do for us is that for us to save time, because you already know that okay, as you develop your application subsequently, that means there will be changes in the application code itself, but not in dependencies frequently. You understand? So you have a session whereby you just installed, you just you built and you fetch all the required packages and dependencies. And another one, everything that you've now built, you now pointed at that environment. I don't know if you get that, but if you don't, next as we actually try to look into that and build it in multi-stage. So the other one like that, you just use it to build the application, copy the code and everything. So I think I answered your question.
Yes, thank you very much. Then the second one is in the ID. That's the Docker ID. You were saying that we don't need to type all the full length of the ID. That we could use
Yes.
maybe. So it means that we can just pick, for example, eight. Are you referring to 8A, for example, 8F21, something like that? Is that the ID, sir?
Yes. If let me try and see the Docker container that we run. Let me see if you can if you see it here now. I have some certain things running now, so I'm coming. Oh, that's not there. But it should be there. Okay. So the Docker run that we just ran is what I was looking for. Basically, let's assume this is the ID for that your container. The container that we run. You understand? It will be as long as this. So if you now want to interact with that container, probably you want to stop or you want to remove. By you just using these first three or more, it will actually work. Just use ED1 or ED18, anything. Docker will understand that, oh, because it's actually unique. So far it's
Okay.
unique, except there's another image that starts with similar stuff. Then you have to increase the number. Yeah. So any other question? Is there another question? So in the absence of any question, I think we've actually come to the end of this first class on this Docker. And so in the next class, we'll be looking to Dockerizing a real application and then try to see how far we can go on it by pushing it to our Docker repository and also see how we can pull it and use it for something better.
So, lastly, sir, just a comment, sir. Uh,
Okay.
at the beginning of the class, Dr. Timothy actually requested us to download the desktop application. So I did, but I didn't proceed with the installation because I thought probably maybe we wanted to highlight maybe some key components. So that means we can go ahead and just install.
Yes.
If, uh, a follow up to that question, I downloaded I downloaded the application and then installed. I was told that it cannot work in my system. I actually downloaded the desktop application, though there are two desktops mentioned there. Mine is just a window, So I don't know. It's that one didn't. Though I'm downloading another one now to see whether that one will work. I don't know. I just want to
Okay.
say
Okay. Which type of Windows are you using?
uh, here is what do you call it? Um, I,
Is it Windows
I don't know
10, 11?
in terms of yeah, Windows 10, yes, Windows 10, and then
Windows?
it, Windows 10, whatever, and then
Okay,
it's
okay.
uh,
Okay, you should be able to install it. Just use Docker Desktop. You should be able to install Docker Desktop on that Windows 10. You should be able to install Docker Desktop.
maybe
And what is the meaning of allow Windows containers to be used with this installation? It's part of that's under the the
The
initial.
installation,
Yes, that's a Windows installation.
it said it to allow Docker container to use what?
Yes, there's an option there. We are supposed to either tick or remove or just
Please,
leave. Allow
just try
Windows
to.
containers to be used with this installation.
Oh, to be used
Should that
within this.
option be selected?
Okay. Basically, I don't even understand what that means. But why I thought
phone
Mr. Mis-
Why?
Mr. Jaji,
Design another one
I
area
think you
maybe
can.
maybe.
I think you have to.
Area
You
the
have
map
to
on your
select that
phone.
option.
yeah.
Wherever here.
Mr.
Phone.
Jaji, I think you need to select that option.
Okay.
Basically,
Yes.
that thing, what I thought it might actually be is that in when you are running container, the container will be running isolatedly from your laptop. It won't be using normal laptop ports at all. So probably that option now, if you tick it, that might mean probably when you wanted to run any container, it will definitely be running directly on your laptop. That it will be using that same port. It's very easy for you to just port, you mat port. You understand? So probably does it. Or not, you can just try and search online more on that. But basically, I'm not. I use Linux mostly, so majority of all those stuff on Linux, on Windows. I don't really, I'm not used to them at all. Yeah. So any question again? So in the absence of any question, I will.
Since you are done, I think by this time we can
Yeah.
close the class, and the recording will be shared with you people online. So thank you very much on these notes. Since there's no question again, I think we can close the class. So thank you. God bless you all.